Here we're asked to evaluate the inverse sine of negative 1/2. I should mention that this expression can also be represented as arcsin of negative 1/2. The inverse sine function can also be referred to as the arcsin function. So when we're working with the inverse trig functions, we have to recognize that the value that's playing the role of the input in these expressions, for example, in this case, negative 1/2 is the input value. The input value for an inverse trig function is the output value for the so-called original trig function. So in order to evaluate sine inverse of negative 1/2, we can think, it's just thinking about it, it's not the same problem, but we can think about a similar situation, the equation where negative 1/2 is an output for the sine function. And we need to find an angle who has an output value in the sine function of negative 1/2. All right, and there's an additional restriction on us when we're working with the inverse sine function. I'll draw a little circle over here to talk about that. So if we have whoa, it got a little sloppy there, but it'll work. If we have a unit circle, we have to recognize that the inverse sine function can only output angles. These angles that the angle that we're trying to find that has a sine value of negative 1/2 has to live in the sort of right hemisphere of the circle. It has to be between negative pi over 2 and pi over 2. So we need this equation to be true, and we need that angle theta to be between pi over 2 and negative pi over 2. This restriction is necessary so that the inverse sine function is a function. Otherwise, the inverse sine expression would end up having more than one output for each input, which isn't allowed in a function. So we need to choose an angle in the fourth or first quadrant, right? Quad 4 or quad 1. We have to have an angle in there, and we need that angle to have a sine value of negative 1/2. Now, with our experience, we know that certain angles do have sine values that look like negative 1/2. For example, we know that the sine of pi over 6 is 1/2. It's 1/2, not negative 1/2, but we're familiar with this fact. And we understand that multiples of pi over 6 will also have sine values of 1/2 or negative 1/2, right? We're familiar with the fact, for example, that 7 pi over 6, if I change the angle to 7 pi over 6, 7 pi over 6 is an angle down in quad 3 that has a sine value of negative 1/2. So 7 pi over 6 sorry, I didn't actually give us a negative sine value. 7 pi over 6 would give us the negative 1/2 sine value that we need. But the problem is that 7 pi over 6 is in quad 3 while we're required to have an angle in quad 4 or 1. Oh no, I got erased a little too much. Get rid of some of that. So 7 pi over 6 won't work. Since we're trying to get into quad 4, you might think, well, how about 11 pi over 6? 11 pi over 6, of course, is the angle that goes all the way around into quad 4 and ends here, where our height would be the desired negative 1/2 value. But the problem with 11 pi over 6 is that it's much bigger than pi over 2. We can't go bigger than pi over 2. So this isn't a correct result, so I'll get rid of that 11 pi over 6 information. And instead, we need to rotate into quadrant 2 in this negative direction, and so that we remain inside the restricted range of our angle. So if we make this angle negative pi over 6, then we'd have a correct statement, right? And this angle negative pi over 6 is in the desired interval. So negative pi over 6 must be our desired sine value. So to conclude, we will need to directly communicate what the given expression equals. So we need to start our response literally with the given expression, sine inverse of negative 1/2, and communicate that it equals the angle negative pi over 6.